Hi all, welcome back to the channel again. So here we are today to solve another daily question problem from LeetCode. So this is problem number 2210, which is about counting hills and valleys in an array. So let's see what is this question about. So you're given 0 index array nums. An index I is part of a hill in nums if the closest non-equal numbers of I are smaller than nums. So, what this statement means is that, so let's say you have a number. Okay, first we'll complete reading the question, then we can go see the examples provided. Similarly, an index I is part of valley in nums if the closest non-equal numbers of I are larger than nums. Adjacent indices I and j are part of the same hill or valley if nums of I is equal to nums of j. Note that for an index to be part of hill or valley, it must be non-equal number on both left and right of the index. Return the total number of hills and valley nums. So what this question is about? So this question, in the end, you have to return the total number of valleys and hills, and the number the current number you're comparing to the previous or the number after that, after the current number, should be non-equal number. It shouldn't be a duplicate of the same current number. Okay, so that is about it. So if we see the first example, we are given an array of 2 4 1 1 6 5. So let's start from index 0. So this index 0 does not have a left element, so we ignore that and go to the first index. So 4. So at index 4, 4 has 2 on the left side and 1 as the right side. So this now we should find out whether it is a valley or a hill. So for that we should compare 4. If 4 is greater than 2 and 4 is greater than 1 as well. If the current number is greater than both of its left and right, it's called a hill. It comes under hill. So we'll go to the next index. The next index at 2, the current number is 1. So the previous number is 4 and the after the right one is the 1. So now 1 is not greater than 4. So 1 is less than 4. And and in this case, at the right side, you can't take its duplicate. You have to find the nearest closest neighbor to that. So the nearest closest neighbor is 6. So now, so 4 and 6. 1 is less than 4, 1 is less than 6. If the current number is less than both of its left and right element, it will come under valley. So that's about it. If we go here, we see so many duplicates. So at index 0, we do not have a left. And same as index 1. 6, we can't compare it with the duplicate element only. So it's neither a hill nor a valley. So this is the problem. So I hope you understand what it is about. So I'll be giving you 5 to 10 seconds of time so that you can go through the question and we can put our thoughts in a coding way. Later in the end, I'll be explaining you pen and paper how you solve this question and how do we actually do this. Okay, please go through the question. I hope you have gone through the question. Let's start how to code this. I'll tell you how you should code this problem. First, what is the output? Return the number of hills and valleys. For that, you should have a count variable, right? So first, I'll initialize this count, and next we can have this n is equal to len of nums, and we will start iterating from the first index. We cannot include the last element and the first element because the first element won't have the left value and the last element won't have the right value. So the indexing will start from 1. The next step you should be careful about is you need not iterate till the end. So if you iterate to the last second element, it is fine because you should have a right element, just like I told you. So we'll have a while loop for this. While I is less than n minus 1. if nums of I minus 1. So we do this because this is to iterate till the second last element, and this condition is for skipping uh, skip if it's the same as the previous element. Okay, if the current number is same as the previous element, we skip this and we go back and find the closest non-equal neighbor. So this is that. And the next one, sorry, I've given the condition wrong. If it is the same one, we iterate the I value and we give continue, right? So we are after we continue, left is equal to I minus 1, because if we have a duplicate number for the current element we are checking, first we should find the closest non-equal number in the left and then we can find in the right. So for this, left is equal to I minus 1, while left is greater than or equals to 0 and nums of left is equal to nums of I, we get left minus equal to 1. So we are looking in the left to find the closest non-equal neighbor. So next, after we did this, see the index should be greater than 0, and the nums of left is equal to current element. We decrement the left and go back and check if we find the current one. Now we have to similarly check for right as well. So right is equal to I plus 1, while right is less than n and nums of right is equal to nums of I. What we'll do, we will go to the next one and check. I mean, iterate through the next element from the right and check. And now we'll only do this, we ensure that we have both the neighbors exist. So if left is greater than or equal to 0 and right is less than n, if nums of I is greater than nums of, now we come to the main part of checking with the logic what it is. If nums of I is greater than nums of left and nums of I is also greater than nums of right, we increase the count plus equal to 1. Similarly, you have to check for the value also. So nums of I is less than nums of left and nums of I is also less than nums of right. We consider this as a value, right? After all this is done, so we will skip, we'll go through the next I. In the end, return count. Yes, it has passed all the test cases and we'll submit and see if it is passing all the test cases. Yes, so we have completed all the test cases. And now, continuing to this, I'll also show you how you can hands-on solve this problem for more clear understanding. So thank you for watching till here. Please continue watching for the rest of the video also.
And now I'll show you how exactly the code works with this example. First step, according to the code we see, the problem is about you have to find the number of hills and the number of valleys, right? So this is our question. So how do we solve using this example? First thing is we'll have a count variable initially as 0. Now next is if we traverse till this element, it is fine. You need not traverse to the end because it won't have any right side value. If you need not consider both the start element and the end element, because the start element won't have a left side value and the end element won't have a right side value. So let's solve how we can do this. So first, if we start from index 0, so let's say first index 0, we don't we as I told you, we don't consider this, so we move to the next element. So I is equal to 1. So let's say this is array. So array of 1 is 4. Now we have to check if it is a hill or a valley. So for hill, what should you satisfy? This number should be greater than this closest neighbor and the next closest neighbor, and this both neighbors should be non-equal. They shouldn't be matching with the current element. So 4, if you see, 4 is greater than 2 and 4 is greater than 1. So it is a hill, right? So we increase the count value here. Count is equal to 1. And next, index 1 is done and we go to index 2. Now, at index 2, array of I is 1. So what is the left value of this? It is 4. So left value is 4, and if you go to the right, it is 1. So you shouldn't what do you say, include this. You should go to the right and check which is the closest one to that. So the next closest one is r is equal to 6. This is left, this is right, and now we should check if it is a hill or a valley. So for this, 1 is not greater than 4. So 1 is less than 4, 1 is less than 6. It will come under valley. So this is a hill, this is a valley, but still will increase the count value. So it is 2. Next, if you go for this also, it's the same, right? So it's the same. So I'll increase the count to 3. And next is the 6. So 6, if you see, 6 is greater than 1, 6 is greater than 5. So if you find the same element, you need not sorry, I told you wrong. So if you find the same element, you can keep the count as same. And if you check with the 6, 6 is greater than 1, 6 is greater than 5. So it will come under valley. So 2 plus 1, so 3. In the end, answer is 3.